All right, so today a little intro to chapters 6 and 7. In 6 and 7, we'll be doing a lot of this going around in circles routine. Okay, so we're going to have rotational motion. And so what I want to talk about today, first of all, is the idea of a radian. And so a lot of people are a little fuzzy on what that means. So what we're going to do is a little experiment. So what you're going to do is you're going to find 10 things in this room that are round. So for instance, on my desk there is a coffee cup. For instance, okay, you could use that. You're obviously going to have to share. There's a 5-gallon bucket on the back of my room. Okay, whatever. Could we, Mr. Grum? Could we use that pot on the top of your shelf that the flag's in? Well, it doesn't really look that round, dude. So no, I'm gonna go with no. Okay, whatever. All right, you do you. Just find me some round objects. What about those tennis balls? Yes, I suppose that would work. What you're going to do is this. You're going to do the following. You're going to measure the circumference. Well, how do I do that? Well, if it was me, I would get a piece of string out of the art basket, which there isn't a ton of string over there because we apparently are short on it. There's some baling twine. You could use a little of that. You could cut a piece of masking tape and then fold it over, so the sticky sides towards each other, and then wrap it around it. I don't really care. Just measure the circumference. Then lay the string out, put it next to a meter stick or whatever, measure it off. Okay, this isn't hard, people. Okay? Now, what I want to know is this. Okay? I want you to find the radius of the object, and I want you to put the circumference right here. Okay? And again, I want 10 of these. So, for instance, 2. Well, the circumference is 37, Mr. Groom. I hope it's not. I just made this number up. It better not be 37. Okay? When you're done, okay, what am I doing this in? Am I doing this in Google Sheets? I suppose. Or Excel? I guess. Whatever, dude. What I want you to do is I want you to graph the radius versus the circumference. Okay? Now, there's a reason I'm doing this. Okay? I'll give you the hint. If the circle has 0 radius, it has 0 circumference. So that's pretty key. What I want to see is this. What does the scatter plot look like? And when it comes up, does it look like this? I hope not. But if it does, then fit yourself a nice quadratic equation to it. Okay? Do a regression on that. Okay? You're like, well, no, Mr. Green, mine's not that. Mine is nice and linear. That's key. I mean, obviously, they're all over the place, but whatever. It's basically linear. Then find an equation for that. Okay? Now, when it's all said and done, here is the question I want you to answer for yourselves. What did you find? Okay? Number 2, like, what is your equation? Y equals blah. Okay? Number 3, yeah, I don't know. 360 degrees is how many radians? Okay, you decide that based on what you discovered in your little lab here. Now we're going to take about, I don't know, 15, 20 minutes to mess. No, let's say 25. Let's say 25 minutes to do this. Maybe 30. The sub will keep track. Okay? And then we'll start this video again when we're done. Okay? Now, run along. Okay. And we're back. All right, now, what I want to do is this. So, today, we've had the following. We've had linear motion. That's what we've been studying this whole time. Rotational over here. Okay? Scream. We have some playas in the linear realm, x, b, t, and a. Okay? Those are all linear velocities. Okay, well, that's nice. Well, over here, we're going to have our linear measurements. Over here, we're going to have different things. So, for instance, in the rotational realm, theta plays the part of x. Theta is the number of radians. Very similar to, but not exactly, the number of revolutions something's going to do. Okay, so it's going to obviously be different than that, but slightly the same. Omega. It looks like a butt. All right, it's just a W there like that. Omega. This is the what we call the angular velocity. Oh, and this is number of radians, but this is called angular displacement. You're like, displacement, just like x. That's correct. Acceleration is alpha. Alpha is angular acceleration. Cool. T, of course, is always time. We've talked about mass quite a bit, yes? Mass. Ooh, who plays the part of mass over here? Turns out mass is played by the moment of inertia. Okay, it's not about the mass, it's about how the mass is distributed. Is it out toward the edges of the thing that's spinning, or is it in toward the center? So back in the day, before the world has become bubble wrapped, we used to have these little merry-go-rounds we used to ride on as children. And the cool thing to do was to start out here at the edge, and then everybody start crawling toward the middle. And when you started crawling toward the middle, what happened? Oh, say it speeds up. Why does it speed up? It speeds up because the mass is more concentrated in the middle than it is toward the outside. This was really fun until someone flew off and got their head banged pretty hard. Then it was really funny. But anyway, so that's kind of a big deal. Now you're like, well, wait a minute. X equals VT, Mr. Groom. So does that mean that theta equals omega t over here? Yeah. This is like with constant velocity. Uh-huh. Well, wait. The grand poobah says 1/2 at squared plus v sub o t. Well, over here, the playas would be this. 1/2 alpha t squared plus omega naught t. Dude, that's awesome. I know, right? How about acceleration, Mr. Groom? So the definition of acceleration is the change in velocity over time. Are you saying that butt would equal, no, I'm sorry, the alpha would equal butt f minus butt o over t? That's exactly what I'm saying. Wait, v sub f squared equals v sub o squared plus 2ax. Are you saying that's going to be exactly the same as omega f squared equals omega naught squared plus 2 alpha theta? Literally, that's what I'm saying. Wait, F equals ma. Oh, well, dude, I totes know this. This is that. Equals a force? Ooh, not so fast, friend. In rotational realm, we have a little thing called torque. So torque, you see, is equal to the moment of inertia times acceleration. Well, wait a minute. What about momentum, Mr. Groom? Momentum is mv. Is there momentum over here in this realm? There is momentum in this realm, and what would it be? It would be I omega. Nice. So all we're doing is just changing out the players. That's right. That's weird. I know. And so you can talk about power. You can talk about all the other stuff. We'll get into more of that a little more in depth later on. But these are the guys that we will be talking about as we go through this chapter. Okay. Again, a little bit of big picture day today in this regard. And so that's kind of a neat deal. Now, what we're going to end up doing is you can equate x and theta if you simply multiply theta by r. You can also equate v and omega if you times not by a theta, you idiot. P times by r. You can equate theta alpha and a if you times by r. That is how you can equate the two together. Okay. I think that's where I want to leave off today. Don't stress too hard about it. But if you remember the players, who the players are, if you remember the players, who takes the place of who, right? If you can remember that, then the equations are exactly the same. All you have to do is sub out the players. Hey, I'm subbing in for you there. Okay? That's it. Okay. All right. Have a good day.